Generally in the 3D environment, but above all in the parametric solid modeling, the management of the work plane is basic. Therefore, from the menu, we have a series of commands to position the trade-off axis. In this case, we applied the select, allowing us to dynamically move the trade-off axis by dragging the arrow of the vector or by dragging directly the origin point to position it in the desired point. Double-click on the round arrows to rotate by 90 degrees the work plane around the axis. Double-click on the arrow of the vector to invert its direction, or by a single click we are allowed to enter the desired value of the angle. All operations useful to position a trade-off axis. Let's bring back the trade-off axis on the absolute reference system, the work plane world. From the specific icon, we activate the Select Face mode, as we need it to select the face, and from the context menu state Work Plane Here, we have placed an XY work plane orientated along the plane face that we have selected, because on this work plane we are going to activate the 2D profile environment, and we draw a shape by the polyline command. We can possibly remove the unuseful constraints automatically added by ThinkDesign based upon the way we draw the geometric entities. Now, we insert a line passing for the midpoints of the horizontal lines because we need an axis. In fact, we select this line and make it a reference. It's an angled line, that's why we add a geometric constraint of orientation, and we fix verticality for this line. In this way, we have entered a symmetry condition. By moving an element on the left, the same element on the right move in correspondence. Now we insert the dimensions we need: length, height, and an angle. Here we are. Better fit the view. Let's fit it. Then we switch to the View menu to adjust Test to the view to manage visualization of dimensions. By a double click, in this case on the dimension, we set it to the desired value, or from the context menu by Edit Dimension. In this case, we type in an angle of 75. On the length dimension, we type in an expression instead. That length will be equal to h divided by 2, a variable that we had previously defined. By Check Profile, we notice there are still some undefined entities, but there are 2 degrees of freedom. So if we move our profile, we see it doesn't change in sizes, but is free to move along the XY plane. Let's now insert a coincidence constraint between the endpoint of our center line and the midpoint of the solid edge. In this case, we obtain a well-defined profile. We use this profile to make a linear slot, that is, a removal of material not passing through, but in blind mode, with a depth value of 10. This is the result we get. Let's bring back the work plane to the position world. Let's view in wireframe. From the context menu in the model structure on the feature, we can select Show Driving Dimensions, so the driving dimensions related to that feature are displayed, or we can select the solid and apply from the menu View Show Driving Dimensions. Otherwise, going back to a feature in the model structure when they are displayed in the context menu, we find Hide Driving Dimensions. Let's go to the spreadsheet, where we have already some variables. We define another one, p, by an expression L divided by 4, We select the row and we assign it to the dimension of the height of our blind slot. Let's rebuild, so the updated value will be equal to L divided by 4. Let's now add a shaft feature. We identify the face on which we are going to position the shaft, the value in height, the value of the diameter. Let's drag the origin of the shaft. We see this position is free, but we are going to lock it. So the position of the shaft will be referred to the midpoint of the axis of the bottom profile. Let's set shaded view, because now we are going to insert on the shaft of face a hole. So, hole feature, not with the value of the screw designation, but with the value as desired of the diameter, 16, the position, in the center of the shaft face, confirmation, and let's save the job done so far. OK.